Continuing with the information model, each of the logical nodes will have one or more data objects. Data objects are complex information structures which already existed in communication protocols prior to IEC 61850. Typical data objects that can be found in the standard include double signals with command, double signals without command, single signals, counters, measurements, settings, etc. As an information structure, data objects do not form a very extensive set. However, they are most significant and most innovative in the sense that when they are instantiated from a logical node, in other words, when they hang from it, their name expresses the specific data in the logical node. For example, in the case of a switch, the logical node called POS is a double signal with command which indicates the status in which the switch is found. However, the logical node called OPCNT is the counter of operations which have been performed on this switch. Therefore, a series of properties or data objects will be obtained from a logical node which will provide information on this functional feature. In this example, the status and command on the switch and the operations counter have been created. In the model which was previously created, you can see that an XCBR has much more instantiated data, for example, the status of the opening block, the status of the closing block, etc. Therefore, a functional feature which is as apparently simple as a switch provides much more information on the status, diagnostics, command, settings, etc. Much of this information is optional and therefore each manufacturer will have to decide whether or not to provide it. Data objects create the functional constraint level. Although the standard defines it as a property which is not directly linked to a data object, it is hierarchically defined both in communications and in many tools in the next level. The functional constraint defines what type of operations can be performed on the information provided by a data object. In this example, the position of a switch has three data items, ST val, Q, and T, grouped together into a status type functional constraint. The functional constraint is composed of two letters, already defined by the standard, and indicates the nature of the data item. As examples, ST is used for status, MX for measurement, CO for command, CF for configuration, etc. The slide shows the complete model of a device. The physical device will be on the first level. It is composed of two logical devices. One of them is the control device, which will have a switch, which will in turn contain a position. This position would reflect its status in three variables: the data item of the status itself, the quality of this data item and its timestamp. These three data items are used to know the switch's current status, what time it switched and if the data is good quality or not. To open and close a switch, in the position data object, a CO, in other words command type, functional constraint must be defined, which will allow you to perform operations on it. The data upon which the operation type is to be performed is CTL val. All of this hierarchical information is stored in an XML file which may be on the device itself, as in the case of INGESYS eFS, or provided with the equipment. Therefore, to configure communication between a local third-party SCADA and an IEC 61850 device, simply import the device's ICD configuration file, which will contain the entire hierarchical model seen previously, and this will automatically recognize all of its information model. In other words, all of the data that the device is able to publish or the commands that it is capable of receiving. Hence, the substation's engineering is carried out much more quickly. In the example, via the IEC 61850 protocol, the local SCADA can request the EFCTRL data from the EF device. In other words, logical node XCBR1 is requested from the IEDEF in its control logical device, then from its data object POS, and in turn binding ST val. The device will answer with the possible values 00, 01, 10 or 11 to indicate whether that particular switch is open, closed, in an unknown status or erroneous. In short, the standard provides the definition of the IEC 61850 equipment's model using an XML file, with a priori complex syntax but which provides a large amount of information, both to someone who wants to read the model and to other third-party devices, given that this information is perfectly restricted in terms of its fields, lengths and types. In the model which we started to create with the tool, you can see that the operations counter which has been defined for this switch has a series of functional constraints, including the status, which contains the value of the switch's status, its quality as well as its timestamp. Each of the data objects will have either a set of bindings directly hanging from a functional constraints, or a set of data attributes. In the IEC 61850 standard, both ST-val and OPA are directly called data attributes. In INGESYS eFS and INGESYS IT, a differentiation is made between simple data items called bindings, that is Boolean signals, floating points, text strings, etc., and complex structures, which would be data attributes. A data attribute is defined when more than one simple data item is needed to express a magnitude. In the case of the OPA command, the CTL-val data item, which is the command value itself, may suffice. But the commands of the IEC 61850 standard may be much more complex. For example, to create a delayed opening or a controls test during commissioning indicating that it is a test which will not really be run, or indicating who will send a command, etc. All this information that a single command may have is so complex that it must be composed of a whole set of data. In the tool, in the switcher's position you may find the value of the switcher's status, the quality and the timestamp, while in the command, not only will you find the OPA data attribute but also there is cancel, select before operate, and select before operate with advanced security. With these data attributes, you can send a direct order or do so using a prior selection or cancel it. In OPA, besides the CTL-val direct command, there may be much more additional information such as OPA-TM for indicating what time the command must be run, CTL-num for counting the number of command sequences, test for indicating the test maneuver, origin to identify who gives the command using an identifier and a category, etc. Since all of this information is more complex than a simple data item, the standard is equipped with a data attribute type structure for this purpose.